Hello fellow Unreal Engine artists, designers and developers. In today's tutorial I'll be showing you how to create this modular procedural staircase using Geometry Script. You will have this user widget that you can use to control things like the height, the width of the staircase, the length of each staircase. You'll be able to change the steps per staircase, have the option between regular solid staircases and floating staircases, and you can also create as many sections as you want with an array of directions here, so you can add in extra elements and choose which direction they go in, and you can see that they are instantly shown in the scene. They adapt to any changes you make in terms of width and depth. So let's get straight in to how to do this. So let's create our new geometry script. So if I go into the content browser, and I'll stick it in this tools folder here where we've done the other scripts from earlier in the series, we'll do a new blueprint class. It's going to be based on the generated dynamic mesh actor, and so select that, and I'm going to call it GS staircase. And let's open that up. Start with a blank canvas here. We go to the event graph and we'll get rid of the current events there. What we need to do, because this is a geometry script, is we need to go to our functions and override the onRebuild generated mesh, which is the geometry script equivalent of the construction script. And because we'll be using this target mesh quite a few times during the script, we'll promote that to a variable, which I will call dynamic mesh. Okay, so the first thing we're going to do is create our base staircase. So we need to set up some variables and calculate some dimensions like the step width, height and depth from that. So let's create a couple of variables here. So let's start off with a variable which we will manipulate the width, height and depth of the staircase from. And I'm going to call this one staircase top. And let's make this a vector value, and we're going to make it editable. But as well as this, if I go over to the details for this, I'm going to check this show 3D widget option here. What that means is that it will actually appear in the viewport, so we can manipulate it directly without having to type in X, Y and Z values. So it's much more user friendly. Let's create another variable here as well, which is going to be the num steps, so the number of steps we want in our staircase, and that will be an integer value, and again user editable. Okay, so we've now created our sort of input variables here. We now need to calculate the dimensions of our staircase before we create it. So let's do a new function for this, and I'm going to call this calculate staircase dimensions. And I'm going to take our staircase top vector and split it into X, Y and Z values. And let's promote these to some variables. So the X is going to be the direction that the staircase goes, the first staircase. So let's promote that to a variable, which I will call staircase length. And attach that to the execution pin. The next variable I'm going to create, the Z value, is the height of the staircase. So let's promote that to a variable as well. And I'll call that, unsurprisingly, staircase height. And let's connect these together. And the next thing I want to do is calculate the step height, width and depth based on these values. So we're going to have to do a few little calculations here, but it's not too complicated. So let's move this along a little bit so we can see a bit more space. First thing I want to do is create let's create the variables here. So let's take the staircase height here and duplicate it 3 times 2, 3, and I'm going to call these variables step height, step width, and step depth. Okay, now we can calculate these. So let's do the height first. In fact, let's just put all these three in here as setters. So with Alt, let's drag all these three in here. So you've got step height, width, and depth. And let's just connect all the execution pins so we don't forget to do that later. Okay, so let's start off with the step height. So we need to take the staircase height and divide it by the number of steps we want in the staircase. And that will be our step height. Now the step width is going to be the Y value of the staircase top divided by 2, because the center of the staircase is at Y value 0. So our Y value is sort of half a step width away from that. So let's take this, multiply by 2, and plug that into the step width. And then the last thing we need to do is calculate the step depth, and that is the length of the staircase divided by the number of steps. And that is the depth of each step. Okay, let's just compile and save, make sure everything's okay there. And we ought to put a little bit of a comment around here saying calculate staircase dimensions. Actually, that's a bit redundant because that's the name of the function, but I'll leave it there for now. All right, so let's come back out to event graph and let's start to create our first staircase. So the first thing we need to do is call that function. So do calculate staircase dimensions. And now we have all of these values here. We can create our first staircase. So drag off here and do add linear. In fact, let's do add stairs, I think it is. So it's not add. I always make this mistake. It's append. I don't know why they did append rather than add, but append is what you want. And if you do append stairs, there's a couple of options here. We're going to be doing linear stairs here. First thing it needs is the target mesh. So let's drag in our dynamic mesh there. That's the thing we're creating. And now we just need to plug in all these values we've just created. So step width, step height, so I'm just dragging these variables in, step depth, let's do a quick compile, everything seems okay. So one thing we also need to do is set a default value for the number of steps. So the number of steps here, we'll plug it in, but also over on the right hand side here, at the moment it's set to 0, so there won't be any steps at all in this staircase. So let's set that to a default value of 10, compile and save, and it's about time for our first test. So let's go back to the main level and drag in the staircase. Okay, and first thing you'll see is that the staircase top is right in line with the start of the location. So let's actually set a default for the staircase top as well. So go back to your geometry script, go to the staircase top, and let's set the X value, which is the staircase length. Let's do 240. The Y is half the width, so 50, and the height. Let's make the height the same as the length. Okay, compile and save. Okay, and now if we go back to the viewport, we have our first staircase. So you can see that the staircase top is placed at the top right of the staircase. If I click on that, I can manipulate it. So I can make the steps wider by changing the Y value. I can make the staircase longer by changing the X value, and I can make the height change by adjusting the Z value. And I can change the number of steps in here as well. So if I want that to be, say, 5 steps, it uses those calculations to divide the length and height by the number of steps. So I can change those as I want. Okay, so that's all looking good. The only thing I want to do before moving on to creating the other multiple staircases is I don't really want to see this staircase top vector in the variables because we're manipulating it visually. So let's just hide this in a different category. So if I go to the script, select my staircase top variable, and I will change the category over in the right hand side to advanced, and compile, go back here, and we can still select it and move it around, but it doesn't appear in the general view. If I want to see it, if I wanted to put some specific dimensions, I could go into the all section, and there it is in advanced, so I could type in dimensions there. But generally I don't want it seen on the screen. So that's our first staircase. Let's move on and do the subsequent staircases. So before we delve back into the coding, I think it's worth just discussing the strategy of what we're going to do for the subsequent staircase sections. So for each section, we're going to create a landing area, which is going to be a square landing around the top of the staircase. And that means that we can then have staircases going off in the forward, left, right, or backward direction from there. So we're going to be creating a cube for the landing. Well, actually not a cube, sorry, a stretched rectangle. Then we're going to decide which direction we want our next staircase to go in and generate another staircase, just like we've done the first one, but going off in the relevant direction. And because we're now up in the air, we're going to generate a base platform underneath it that goes from the ground level up to the base of the new staircase. So we need to create 3 things for each staircase section: landing, staircase, and base platform. But the first thing I want to do before even doing the next staircase is I want to set a point which is the starting point for the staircase section, and we can amend that as we create each section. So I don't want it to be here in where the staircase top is. I want it to be in the center of the landing we're going to create, and that way it's going to be symmetrical whichever direction we go in. So let's create a new variable and make sure it's calculated to be in the right place. So back to the blueprint, let's go to the end of the code, and what we'll do is we will actually first of all create a new variable. So new variable, and I'm going to call this current staircase base. It's going to be our base point from which we build the next section, and this is going to be a vector. And let's use Alt to drag this into the level and connect it. So we're going to be setting this, but we need to choose the values that we set for the first base level. So let's split these into the X, Y, and Z value. And we're going to be using the staircase top value that we're manipulating as the starting point for this. We'll just do a little bit of manipulation of it. So drag this staircase top in here, and again split it out. Right, and in terms of the initial values, so the Z value is the height. Well, that's the same height as the staircase top, so let's just drag that straight in. The Y value is actually, the initial one is actually 0. So everything is in local space in this geometry script. So our staircase is 0, 0, 0, and so the Y value stays as 0, which is in the middle of the steps. So that's fine. And then lastly, the X value, we need to adjust that by half a step. Now half a step is the Y value. So all we need to do is take the staircase top, do an addition and add the y value, i.e. a half step width, and then plug that into the x value. So now we've got the current staircase base set, and let's visualize that. So let's make it temporarily, let's make it instance editable and show it on screen. We'll make it invisible later on, but it's a useful debug aid to see if it's in the right place. So compile and save, and let's go back to our viewport, and you can see now the current staircase base is hovering somewhere in the middle of this landing area. And if we adjust the staircase here, you can see that as I make the staircase wider, the staircase base goes into the middle of a larger landing, and it also moves with the height and the depth. So it looks right, but only time will tell when we actually do the next bit of coding. So now with this current staircase base in place, we can now go on and create the code for our subsequent staircase sections. All right, so I'm back in the geometry script, and let's put a little comment around our initial nodes and say create initial staircase. And now let's create the variables to drive the additional staircases. So let's go into our browser, and what I need to do is just create a new enumerator to store the values for the directions. So right click, and under the blueprint section, choose enumeration, and I'm going to call it E stair direction. And open that up. I want the ability to have one of 4 directions. So I'm going to do 4 values here: forward, right, backward, and left. And these are going to be the directions relative to the forward direction of the first staircase. And we can always rotate the staircases afterwards, so it's just really for setting up. So save that, close that down. And now we need to set up a new array in our geometry script that the user can add to. So go into your variables, add a new variable. We'll call this more stairs. The type is going to be the E stair direction that we just created. So click on that and make sure it's user editable, and if you right click here, it'll change it into an array, so we can do multiple staircases. And we want to move this up underneath the number of steps. I just like to keep all of the user editable variables together. So let's just add one of these into the staircase that we've dragged into the scene, just so we've got something to use. So let's do a quick compile, go back to the scene, choose the staircase, and we will do, in more stairs, we'll add an element here. You can see you've got the choice between forward, right, backward, and left. We'll just use a forward at the moment. We'll come and play with this later. Okay, and let's come back here and start to use this. Let's start to go through those staircases, and we'll create the landing first of all. So let's use a sequence to tidy this up. I'm going to drag the first 2 nodes back, and I'm going to insert a sequence node in between there and the create initial staircase. And now we want to go on and do our next step, which is to go through each of the more stair directions. So let's drag this in, and let's close her in so you can see a bit more what I'm doing. Let's do a for each loop. So we're going to go for each stair direction that's been requested. Let's connect that to the sequence pin. We want to process them. We've only got one at the moment. So we're going to start off creating a landing section. So I'm going to do it in a function. So create a new function. I'm going to call it create landing. And we are going to use another geometry script function, which is append box. And at the end of the day, the landing is just a box that goes from the ground level up to the top of the stairs. So we really need to look at the transform and the dimensions in order to get the right shape. So let's start off with the transform. We've got this new variable we created, the current staircase base, and so that is in the middle of the landing that we're just about to create. So let's bring this in, split it into X, Y, and Z. And for the transform, we need to, well, let's make a transform first of all. So if I right click and do make transform, we can now start plugging things in and split the location pin as well. Let's create a little bit more space here. So the transform location is going to be the X location, the Y location, and the Z location is going to be 0 because we want the landing to always start at the floor level. So this can now be plugged into the transform. So that'll be the point at which the box is created, this being the base, the transform being the base of it. Right, now let's look at the dimensions. So the X and the Y dimensions are the same because it's a square landing, and they are the width of the step that we created. So let's put in the step width here, there, and the Z dimension is the staircase, the current staircase base. So effectively we want the staircase to go, let's move that down here a bit. We want the staircase to go from the ground level of 0, which is in the transform, to the level that it's been created at the top of the staircase. So let's compile and save that. And now if we come back to, the event graph, we can now attach that function to our loop body for the staircase. So we will drag out here and do create landing. And at this point in time, we don't care which direction we're going in because the landing is always going to be square at the top, whether we're going forward, left, right, or backwards. This will always be in the same location, i.e. the current staircase base. So if I compile and save, come back here, we should have a staircase base there, but I think I've forgotten to plug in the dynamic mesh in the function. So yeah, sure enough, I've done an append box, but I haven't plugged in the dynamic mesh variable. So let's do that. So now it's appending it to the dynamic mesh that it's creating. Should now work. And there we go. So you can see that we now have a square landing. The current staircase base is in the center of it, and it should adapt to any changes. If we go to the staircase top, you can see that as I stretch it, shrink it, it's always going to be from the bottom of the ground to the top of the staircase and the right width and depth. That's good. Now you'll notice that the UV scaling is off here. Don't worry about that. At the end of the tutorial, once we've built everything, we'll remap the UV so everything is consistent. So we now have the landing. Next thing we need to do is we need to create the next staircase. Back in the geometry script, I'm going to create another new function, and this one is going to be called create staircase. And to start off with, we'll just do the standard append staircase, and then we'll start to work out what the location and transformation is going to be for that staircase. So in fact, there's one thing I'm going to do first of all. This staircase ultimately will need to know which direction it's going in. So let's add a new input parameter. We will call that staircase direction. and the type is the E staircase enumerator that we created earlier. Okay, and let's now create a new staircase. We'll then worry about the dimensions and the transformations. We'll sort of work backwards. So I'm going to do append stairs, and we want to append linear stairs again. And I won't make the same mistake as last time. I'll remember to plug my dynamic mesh in to the function. Okay, now let's work out the step width, height and depth first, because these are the easier parts to work out. In fact, it's all the same as before. So we can drag in the step width, the step height, the step depth, the number of steps. So this is all exactly the same as before. Because the staircases are identical, it's really just the rotation and the location of them that changes. So what we want to do now is we want to work out the transformation, location, scale, rotation of this. So let's start off by getting our current staircase base. And what we'll do is we'll do this in stages so you can see how this works. So let's split that out into X, Y and Z. And we need to also create a make transform between the location of the base and the transform that we're creating. So again, let's create a little bit of extra space here to put this in. And let's split our location in this make transform as well, so that we've got X, Y and Z pins. Okay, let's try just putting in the current location and just see where it ends up. It's always worth sort of experimenting as you go through, just to see what the situation is, and then we can make the adjustments as necessary. So let's plug that transformation in to here, and at the moment we're just using the staircase base. So let's compile and save this. We need to attach that this function in our event graph. So let's drag out here and say create staircase. And the direction will come from the array element of the loop. So at the moment we only have one more stair element, but if we have more we can obviously iterate around here and create landings and staircases for all our sections. So let's compile and save that, come back here, and we have a new staircase. But you can see that it's, although it's the right sort of shape and size, it's starting at the center of the landing, and depending on whether it's forward, left, right or backwards, we want to adjust this by half a step width in that direction, or backward or left or right, depending on the direction we've chosen. So we just need to do a little adjustment of the this location in order to push this into the right place. We'll also have to do rotation as well, but we'll consider that in a minute as well. So let's come back to the geometry script. Let's go into our create staircase section, and what we'll do is we need to do something between the X and the Y, but it's based on the direction that we're going in. So I'm going to create a function here to adjust the X and Y depending on the direction, because we'll be doing this a few times. We'll be doing it for the base as well, so it'll be useful to have this adjustment function. So if I go into the functions, create a new function, and I'm going to call this XY adjustment. It might be unclear why I'm doing this, but I'll try and explain it as we go through. So this is going to depend, the adjustment is going to depend on the staircase direction. So again, we'll create an input, and this is going to be staircase direction. and make sure you set it to east air direction, because the last one I set up was that. It's kept it as before. And what we're going to do is we're going to change the amount based on the direction. So let's drag out here and do a select. So you can see that it's going to allow me to choose different values depending on whether it's forward, right, backward or left, and duplicate this and again connect it. Now we also need to pass it in the X and Y values that we want to adjust. So let's do the X in, which is going to be a float. And I'll duplicate that. I can't duplicate it there. Let's just add another one. And we'll call this Y in. That's also a float. And we also need to put in the amount that we're actually adjusting. So in this first case, it's a step width that we're adjusting. But for other elements like the platform, we will probably adjust it by the length of the staircase. So we need to add one more variable, which I'm going to call adjustment amount. And let's just move this beneath staircase direction. Okay, so this is the amount we want to move the X and Y position depending on the direction. So let's do our outputs, because we're going to get from here X out and a Y out. Okay, and the X amount is going to have something added to it. We don't know what yet. And that's going to go in the X out. And the Y is going to have something added to it. So I'm doing a plus there. And that goes to the Y out. Okay, now we need to decide how much to add based on the directions. So if I drag out of here and do a multiplier, and let's just move this. I'm using Control to move it down to the bottom. Oop. I should now be able to connect this to that, and now we have floats coming out of here. And let's duplicate this again and adjust this to connect this to the adjustment amount and the return value. Okay, just move this a little bit over, just a bit more space. Okay, and so the values are dependent, or sorry, the value that I'm adding is dependent on the direction I'm going. So for the X position, if I'm going forward, I want to add 1 times this adjustment amount. If I'm going right or left, I don't want to add anything to it. But if I'm going backwards, I want to subtract that amount. So that's the multiplier of the adjustment amount, and then we add that on to the X value and return it. So for the Y values, let's move that over here a bit. For the Y values, if I'm going forward or backwards, I don't want anything added to the Y value. So I'll leave that 0. If I'm going to the right, I want to add 1 times that amount. If I'm going to the left, I want to add minus 1 times that amount, effectively subtracting. And so that now gets added to the Y value, and that goes in here. So again, I've got the whole thing there. You can pause if you want. Might be scratching your head a little bit here, but all this is doing is, depending on the direction, it's adjusting the X and the Y values so that they are at the right location for the staircase. So let's do a compile and save, and then we'll come back to the create a staircase section here, and we can now use that adjustment amount for the X and the Y values to put it in the right location. So let's take our XY adjustment function and drag it in here, connect it up. Might have to move this back slightly. And don't forget to connect it onto the append linear stairs. Okay, so we've now got our current staircase. So let's put the X and the Y into the adjustment, and the X and the out and the Y out into the make transform. Okay, so now we need to, let's just reroute this so it's clearer what's going on. Okay, now we need to say what direction we're going in and what the adjustment amount is for this particular append. So the direction is the direction we're passing in from the loop, and the adjustment amount here is, if you remember, we're currently in the center of the landing, so we need to move half a step width in the direction that we're doing the staircase. And we've already discussed that the Y value of the staircase top variable, the one we originally created and moved around, if I split the structure pin there, the Y value is half of the step width. So we can take that and put that in the adjustment amount. So we're taking the X and Y values, we're adjusting them by half a step width in the direction of the staircase. Okay, and that should be working. So let's compile and save. Okay, so you can see that it has now put the next staircase in the right location for the forward direction. The question is, will it work for the other directions as well? So if I change my forward element here to right, so it's in the right location. You see it's starting there, but it's not in the right rotation. If I do left, it's starting in the right location, halfway on this side, but it's not rotated correctly. And if I do backward, it's starting the right place here, but it's not pointing backwards. So we've got to sort out the rotation now. So let's put this back to forward for our testing purposes. Do a quick save of the project and go back, and now let's sort out the last thing here, which is the rotation. So when we're creating the staircase here, first thing we need to do is work out the rotation based on the staircase direction. So we need a variable for this. We can make a local variable because we're only going to use it within this function. So down at the bottom here, add a local variable, which I'm going to call staircase rotation. This will be a float. And what we need to do is set this. So let's use Alt to drag it out, connect it to the execution pins, and now we need to set this staircase rotation. At the moment, actually, I've noticed it's an array. Make sure that you right click it, change the variable type, so it should just be a single float. So make sure it's just a single float. And now take our staircase direction, do a select, connect it to the float value, and just like we used it in the XY adjustment, we can now set rotation of the staircase based on the direction. So it will be, if it's forward, we don't need to change the rotation. If it's right, we need to change it by 90 degrees. If it's backward, it'll be 180 degrees. If it's to the left, it's 270. So now our staircase rotation is the right value depending on which direction we requested the staircase. And we now need to plug that rotation into the append linear stairs over here. So let's just spread these out a little bit more so we can read them more easily. And the transform contains the rotation. You see there's rotation, and we want to rotate it on the Z axis. So I've just split this out into rotation X, Y, and Z, and now I can take the staircase, or take out the Z value here. So get staircase rotation, and the rotation now should be correct depending on whether it's forward, backward, left or right. So let's compile, save, and see if that's the case. Okay, no change on the forward direction, so that's a good start point. Now if I do left, not only does it start in the right location, but it's rotated in the right place. If I do right, it starts in the right place and it's rotated. And finally backward, that's fine. It starts at the right location and goes in the backward direction. So that is all looking pretty good. So we can now move on to the next part of the staircase, which is the platform, or the base platform underneath it. Before we create our staircase platform, let's do a little bit of tidying up. I'm in the create staircase function here. So what I'm going to do is I'm going to drag around all of these elements except for the select and the setting of the staircase rotation. And I'm going to put a comment here that says create staircase section. Let's just move that over here. And I don't like to have long cables that go between areas. So let's disconnect this one here that says staircase direction. And then we can plug it in directly by dragging out here and typing staircase direction. And we'll get the variable. And that's now clean and sort of all contained within that comment section. Okay, so we want to move on and do the platform here. So what we'll do is we'll just move this back slightly and use our old friend the sequence to organize this. So we've created the staircase section. Next thing we want to do is create the base for that section. So let's drag out from the next pin, and the base is going to be a box. So we're going to do a bend box. Don't forget to drag the dynamic mesh into the target mesh. And then we need to start thinking about the dimensions and the transformation here. So let's start off with the dimensions. So the X dimension is the length of the staircase. So the box has to cover the whole length of the staircase. So we've already calculated the staircase length. We can drag that in. The Y dimension is the width of the step. So we can drag in the step width for the Y dimension. And then the height of it is in our current staircase base. So that's the height that we want to create. So we'll take in the current staircase base, split it up into X, Y, and Z, and we'll plug the Z into the height value there. So that will give us the right dimensions of the base platform. Okay, that's all good so far. Next thing we need to do is decide where it goes. So what we can do is we can take our current staircase base as before. We will do make a transform. Split the location into X, Y, and Z. And we will put in the X and the Y here. The Z location, just like with our landing, is always going to be 0. We're always going to start at the ground level and create the box up to the bottom of the staircase. So plug that into the transform. Now we haven't quite done everything yet, but let's just see what it's created. Let's see if it's the right dimensions. Do compile and save. And let's go back here. And I don't know if you can see, but it has created the base in the middle of this landing, because we haven't moved it into the right. We haven't adjusted it dependent on whether it's forward, left, back or right. So it doesn't really matter what we create here. This is always going to be here. So we need to make sure that's adjusted in the X and Y plane to the right location, and we need to rotate it as well. So let's go back to our script, and we need to use our old friend that we just created, the XY adjustment. So drag this in, and we're still having to tidy this up a bit now. So let's move all of this along a bit. Let's adjust this so that the first node is the XY adjustment, and then we go to the append box. Okay, let's move this all back a little bit. Right. Okay, so let's disconnect these. I'm using Alt to disconnect them. Location Y, and let's put a little reroute here. Okay, so we need to plug in some values in the XY adjustment here. First one is the staircase direction. So we can get the staircase direction here, plug that in. The next one is the amount we want to adjust by. Now, if you think about where the base is at the moment, it's right in the center of the landing. We do want to move it by half the step width, but we also want to move it by half of the length of the staircase as well. So what we need to do is we need to take, well, let's calculate the staircase length first. We need to divide that by 2. That'll give us the halfway point in the staircase. Oop. Trying to do too many things at once here. Divide by 2. Okay, that's our halfway point down the staircase length. And what we need to do now is add on here the width of the half the width of the staircase, which, as we know from earlier, is the our widget Y value. So let's take in our staircase top widget, split it into X, Y, and Z, and plug the Y into here. So let me just put these together. And now what we have is, let's move that around. So we now have the half the staircase length plus half the step width, and that is the value that we need to adjust that platform by. So take a moment if you need to think about that length there, and we'll plug that into the adjustment amount. And then finally, we'll plug in our X and Y values from the current staircase base. And the output will go into the making the transform here. Right, so we've done everything except the rotation now. So let's actually finish this off and do the rotation. So let's split this up into X, Y, and Z, and we've already calculated our rotation. So if we take the rotation on the Z axis and do get staircase rotation, that should rotate it to the right orientation as well. Okay, let's hope this works. Compile and save. Okay, well, for the forward direction, it works. So you can see that there's my staircase section. Here is the platform. So it's been created in the right dimensions, but it's also been moved here, which is half the length plus the step width. Let's see if it works for the other directions. So let's do left, right. Looks good. backward. It kind of works, but you wouldn't do backward after a forward. And left is all working very well. And let's see what happens if we change the staircase top. So if we make it narrower, you can see that everything adapts. So the step width changes and all of the landing and the platform are all recalculated correctly. If I change the height, that all works. If I change the length of the staircase, it's all working nicely. So all looks good. What we need to do next is we need to now recalculate the current staircase base. We can go around our for loop, just creating as many staircase sections as we want. Again, let's do a little bit of tidying up before we move on to the next set of nodes. So the ones we've just created here, we'll select them and create a comment which says create base platform for stairs. Okay, and let's just put this under the first section. Okay, so now we need to, the final thing we need to do is, if we want to do this again, we need to reset the current staircase base to the top of this staircase in the middle of the landing. So let's add a new pin here and let's start to create the nodes. So we'll need to create another XY adjustment. I'll put it in now because I know we are going to need it. And what we're actually going to be doing in this, let's zoom in a bit so you can see. What we're actually going to be doing here is taking the current staircase base, so let's take that out and split it. And then also take it out again with the Alt key. Sorry, not the rotation. We're taking the current staircase base. Again, split it. So what we're doing is we're going to take the current staircase base and we need to adjust the X, Y, and Z values to reset it to the top of the stairs in the middle of the landing for the next staircase. So we need to think about the right values to put in here. So the staircase direction, actually let's do that in a minute. Let's think about these values first of all. Let's talk about the height. So this is the current height of the staircase. So we really need to just add on the staircase height in order to get the new one. So that's easily done. Take out here, do a plus, get our staircase height, and that is our new value. So we've raised the staircase base by the height. Okay, let's now do the X and the Y values. So let's plug those in to our adjustment, because the adjustment depends on the direction. And then let's plug the outs into the X and Y here. Right, staircase direction first of all is nice and simple. Just do get staircase direction here. And now we need to think about the adjustment amount. So we need to change the X and the Y. It needs to go up by the length of the staircase plus the width of the step. Let's take out the staircase length and the step width and add those together. And we'll put that in the adjustment amount. And now let's connect this to the new pin here. So connect this to here. Let's comment this and say set new base stair location. Again, just align it for neatness. Compile and save, And although we're not creating another staircase yet, we should at least be able to see where that current staircase is, because we've left it as instance editable and showing the widget. So at least we'll be able to see where it is. And sure enough, we can see that in this case, it's up at the top of this staircase in the middle of the landing. If we change the direction to right, you can see that the new current staircase base is there. Left, the new current staircase base is roughly in the middle of that landing. So it looks as though it's in the right location. And now we can do the same as we've done from this point all over again. So we can create landing, stair, and platform in a particular direction. So we're pretty much done. We just need to add some more elements in here. And in fact, we should straight away be able to just say, let's add some more elements in. There you go. Added a forward one, and it's gone from there. If I add another one, and let's make that one right. That works. And we can go to our staircase top here, and we can adjust any elements we want. So let me just move down here. Let's make it a little bit smaller so you can see everything comes down. Let's make the staircase width and staircase length a bit wider. So it's all looking good. It's adapting straight away. Let's now get rid of this staircase base visualization, because I don't want to see this when I'm creating it. It was just really for debugging purposes. So let's come back here, choose our staircase base, and let's switch off instance editable and the show 3D widget. So now the only widget we see on the screen is the one we want to adjust, the staircase top. Okay, that's looking pretty good. Okay, there's two more things to do. First one is let's give the user the option to create floating stairs. And then after that, we'll sort out the materials to make sure that they are scaled in the UV properly, because you can see that I've got different UV scales for different elements. Adding a floating staircase option to this is dead easy. The first thing we need to do is add a new variable. So we'll call this floating staircase. It will be a type of Boolean, and it will be something that the user can choose whether to switch on or off. So we will put that between the num steps and the more stairs array. Do a compile. It's unchecked at the moment, so that will be the default option, not a floating staircase. And now we just need to plug that in. So if you go to the event graph where we create our first staircase here, you will see, if I zoom in a bit, there's an option for floating staircase on or off. So all we need to do is take that variable and plug it in. And similarly, if we go to the create staircase function, the one that does our loop, then again, the first section where we're creating a staircase, we've got the floating option. So we can plug the floating staircase variable into there. The only other thing we want to do is we won't want to create a base platform if we've got a floating section. So all we need to do there is do a branch. Let's actually move this back a bit so that it doesn't get in the way. So we'll do B for branch, plug that in here, and plug in our floating staircase option. And we only want to create the floating, the base platform if it's not a floating staircase. So from the false here, we will connect it to create the base platform for stairs. So compile and save. If we go back to our viewport, nothing should have changed at the moment. But if we click on our floating staircase, you will see that now all of the staircase sections are floating in the air. I have left the landing section in. You will need something there. You might want to change it so that it starts just on the last step, but I'll leave that as a homework exercise for you. really all you need to do is change two dimensions. You need to change the height of the landing and the starting Z point based on the step width. No, not step width, sorry, the step depth. So have a go at that if you want to have a floating landing as well. But this is now done, so we can switch between solid and floating values there. So we just have one last thing to do, and that is to look at the materials and make sure the UV scale is consistent across the whole of the mesh. Let's change the material on the staircase so we can see more clearly what's going to happen when we sort out the UVs on it. So go to the materials element here in your staircase, which is part of the standard generated dynamic mesh, and I'm going to put in the brick wall structure that I've used in the past. And if you go here, you can see that it's a kind of a mishmash of scales. So in the landing we've got a very dense brick structure. The side here we've got larger bricks. The staircase top doesn't look good at all. It looks stretched and tiled, so we need to adjust that. Luckily it's a very simple thing to do. So what we will do is go back into our geometry script, go to our main event graph, and we're going to add one last step here. So let's again tidy up. So this was the loop going through each stair section. Let's comment that and call it create stair sections as requested, and move that there, and then we'll add another pin here, and now we're going to do the logic for creating the adjusted UV scale. Now if I go back to look at the staircase, I notice that all of the planes in this mesh are aligned to the X, Y or Z axis. So it's perfectly horizontal, vertical and structured in that orthogonal way. So we can use a box projection for our UV scales and know that that will work nicely. So come back to here, and if you right click in some empty space and start typing set mesh UVs, one of the options is box projection. So that will set the UVs based on the X, Y and Z scale, and it requires a box transform here. So let's do our old favorite node of making a transform, and we will plug that into the box transform. And also don't forget to connect the dynamic mesh to the target mesh. That's the one we're changing the UVs for. Now the other values you can change if you want. The UV channel, this is assuming that it's only a single UV channel, which ours is. You could probably try with this. I've left this at the default, so again you have to do some experimentation, but I found this works fine. What we're going to do though is we're going to change the scale of the UVs depending on the user input values. So that means we're going to create a new variable. We're going to call it UV scale. It's going to be a float. It's going to be user editable, and we will put that just before the more stairs array here. And now we can plug that in. In fact, what we need to do is just split the structure pin here on the scale, because that's the scale what you want to change, and then drag that in here. Actually, you might have to just drag out and to get UV scale, and then plug that into all three values. So we're going to get a uniform scale on the X, Y and Z axis. And let's compile this and just set a default value. The UV scale, let's just set it to 50. It's all going to depend on the material you put on it, so it will undoubtedly change anyway. So let's compile that. Now we need to just connect that. So go to the pin that you just created up here, connect it to the UV box projection, and let's finish commenting while we're here. Let's just go around here and put a comment that says UV box projection for material and just set that to the aligned location. Okay, so compile and save. Come back out here. Now you can see that something's happened. It's now at least tiling uniformly, so that's good, but it's way too tightly tiled at the moment, but at least it's consistent. So what we need to do is go back to our UV scale and change the value. So let's up it up to 600, and let's get a bit closer to see what's happening. And you can see the bricks are at least consistent there. Maybe could even go up to 800, something like that. And you can see now that all of the planes are looking good. So the side here has bricks, side here on the Y plane, and even the landings on the Z plane, not sorry, the Z plane, the XY plane are looking good as well. So that's looking pretty good. So we can change materials, we can adjust the values here however we want, and it's all looking pretty good. The other thing I mentioned earlier is that this is all happening in local space at the moment. So this concept of forward, left, forward, right is just in relation to the initial staircase. So if you create something and you then want to change its orientation, that's fine. Just select the staircase, go into the rotation, and you can see that it all works fine. It's all relative values. So you have no problem at all in creating staircases that can fit into different scenarios. So that's where I'm going to end today's one. I hope you've found it useful and informative. As always, stay subscribed, and I'll continue with another in this series soon. Bye for now.